Hi everyone, I will be talking with you today about LignoBlock, which is a new sustainable construction material, and I performed an application and techno-economic analysis. First, meet the team. My name is Izzy. I'm an MBA and E-IPER student. I'm passionate about the built environment and hoping to pursue the built environment post-Stanford. I worked with Barney, who's a PhD student here, who's the scientist or the chef behind the bricks. My advisor was Professor Lepec. And this project is put on by Shell. They're a partner in it, so I also worked with Robbie Hedrick. He acted like a secondary advisor. Today we'll cover the problem, the many challenges that come with the built environment. We'll move into the two-phase approach I used, and then finally we'll discuss the key findings, including a positive net present value and an internal rate of return over 20%. All right, the problem. So probably not surprising to anyone in this room, but the built environment, which includes everything that's built by humans that we live in, work in, engage in various activities in, is all around us, and it comes with a multitude of challenges. This includes using half of global extracted raw materials, producing 40% of global emissions, and contributing up to 1/3 of global waste. So in response to try to address some of these issues, Stanford and Shell teamed together to develop a sustainable construction material called LignoBlock. LignoBlock has 3 components. First is sand. That's the core material that makes up the bulk of the block. Second is dimethyl sulfoxide, which is a solvent. You can think of it as a dissolver. Essentially breaks down the other materials so that they can bind together. And third, lignin. You're probably wondering, what the heck is lignin? It is an extremely abundant natural polymer that's found in most plants, and it's what provides the strength and rigidity to plants, specifically within the cell walls. Why would we want to use it in these blocks? The short answer is it's a form of carbon capture. Lignin has a 60% carbon content, and right now, lignin is primarily being used in the paper and pulp industries, and it's being released as a byproduct, and then 98 to 99% of that lignin that's a byproduct is being burned. So all that carbon's being released into the atmosphere. Lignin's also important because as biofuels are increasingly required and become more and more important, lignin is being put in those biofuels, so there's expected to be an available supply of lignin that just increases over the next few years. And so that you can see the magic of lignin, you can see 4 different blocks of the same size compared. The blue box is lignin, the other are 3 common bricks, and you can see LignoBlock has a negative emissions profile, while 3 other common bricks all have emissions ranging from 2 to upwards of 3.2. All right, so my approach to this techno-economic analysis was 2 phases. First, I needed to figure out kind of what use case to do a techno-economic analysis on. So I looked at clay bricks, concrete bricks, and sand lime bricks, analyzed them across 7 criteria, including density, strength, market size, production method, recyclability level, and ultimately found that clay bricks present the biggest short-term opportunity, and that's what we should tackle first. So using that, I did a techno-economic analysis that had a variety of components that I'll talk through. Okay, so key findings. First, when we look at geography, I found that Texas is a strong potential LignoBlock market. I am biased because I'm from Texas, but there are actually 3 key reliable reasons. First is there are a plethora of natural gas plants and petroleum refineries in Texas. That's important because, as I mentioned, lignin is expected to be used more and more in biofuels. And so it's expected that these refineries and plants will start having lignin supply in them. So we want to be near big supply of lignin, a large supply of lignin. Second, Texas already has a big clay brick production volume. It's produces the third most bricks by revenue of all the states. And finally, Texas is very vast, and it has a very diverse set of lignin that we'll be able to pull from. Second, I looked at the processes. And the key takeaway here is that the lignin production process closely mirrors the clay brick production process, which you can see up on the screen. But there are some key differences, and they do have environmental and financial impacts that I'll call out. First is a lower carbon, first, instead of using clay, we're going to have to use sand and lignin, which is going to result in a lower emissions profile, but it will have increased costs. And I'll put numbers to those costs on the next slide. Second, instead of just using water as that solvent or that dissolver material, we're going to need to use the dimethyl sulfoxide, which is also going to have increased unit cost. Third, we're going to need a way to capture that DMSO. So we're going to have to increase our capital expenditures to capture that DMSO exhaust and recycle it. And fourth, in an ideal state, both Shell and the Stanford team believe that we're going to be able to dry these bricks both in a shorter time and at a lower temperature, which will reduce the energy required and ultimately lower the capital expenditures. All right, so now we can look at this on a per unit basis. You can see in the middle, the white column, that's the clay brick price on a per unit basis. And then on the right, we have the LignoBlock brick. The red cells are those where the cost is higher than that of clay brick. The green are those where the cost is lower. Big takeaway here is that the total cost of clay bricks is about 25 cents, while LignoBlock bricks is about 44 cents. Primary driver of that is the core materials, the lignin and the dimethyl sulfoxide. And finally, kind of the so what of that is that we're going to have to charge a higher price for these LignoBlock bricks. We can likely charge at the high end of the clay brick prices, which is around that 75 cents mark, but there may be some risks, which I'll discuss at the end. Once I had that unit analysis, I did an NPV analysis, or a net present value analysis, based on the some key assumptions. Three I'll call out is a 20-year project life. Second is a market share. I believe we can capture 0.4% of the Texas market in the first year and steadily increase that at about 0.15% each year. And I used the brick price of 75 cents, which is the high end of the clay brick market now. Results of that were that we can break even in year 5, we can have a positive net present value of 29 million, and an internal rate of return over 20%, which are really good metrics. But there are risks. First is that clay bricks have become commoditized, so many buyers expect low prices, may not be willing to pay these high-end prices. Second is building contractors frequently have long-established relationships with brick suppliers, which might make it more difficult than expected to steal the market share. Because of this, I ran some sensitivity analysis looking at unit sales price and market share, or year 1 market share. You can see in light blue is the base case, and not surprising, as you reduce your cost or your sales price and you reduce that initial market share, you quickly creep into negative net present value territory. However, in talking to experts in this space, many are confident that LignoBlock will be able to achieve that 75% sales price, and that many customers, especially as regulation continue and people want to decarbonize the industry, LignoBlock will be a success and will be able to be sold. Thank you. Any questions?
First of all, thank you. And I apologize if I misunderstood this, but so with lignin as a byproduct right now, what's keeping those costs so high? And how would you improve that?
Yeah, it's a good question. Right now, the costs are high. So lignin it's kind of confusing. Lignin's in most plants, but right now, a ready state of it that's separated from the plant is mainly only coming from paper and pulp. I think it's expensive right now because so much of it is just going straight to being burned that there's not just a large supply readily available that you can buy. But the hope is that as you come up with more use cases for this lignin, hopefully a better market will exist for it and that price will come down.
I'm curious if you've seen in your work any policy or regulations right now that could be productive for supporting this in the future, because that was one of the things you said at the end that was a big limiting factor. Is there anything on the horizon that you're seeing?
That's a good question. I don't have a specific regulation on the horizon. I will look more into that, but I think in general, with all these things we're presenting on, the trends are more towards decarbonization and built environment, with it being 40% of global emissions. It's such a hot topic that it's coming for sure, but I don't have a specific regulation. I'll look into that.
I love all this built environment stuff. This is great. The question that I had was more on the demand side. In your NPV calculation, obviously it's super sensitive to both the price and a market share. So do you have a view of kind of the customer profile over time? Like, who are the early adopters of this? And then how do you transition that into more quote unquote traditional contractors, or like who is it that's buying this initially and then in the longer term?
Yeah, great question. So right now, that high end of the clay brick prices is about 75%, and typically those bricks are more of the kind of special, unique bricks from my understanding. And so I think we're going to need customers, one, that are working on decarbonization, that are willing to pay that premium. And my hope is that with regulations, with increased concern about the environment, and as we scale this up, hopefully prices decreasing as lignin gets cheaper and everything else, that more and more customers will be able to continue to steel. But at first, it's going to be those customers that care about the environment and have the money to pay.
Another comment, which also might pertain to Corey's project, is have you given any thought yet to strategic collaborations, for example, on this market acceptance, working with architects, construction? You know, just a shout out maybe to the other part of CEE that does sustainable construction, to at least educate the architects, engineers, and construction companies, if not do formal or informal, joint ventures with them.
Yeah, so something I've thought about is definitely there's going to be a training component to it, but also either collaborating with all the folks you mentioned, or even a big traditional clay brick manufacturer like an Acme Brick who's all over the US, and maybe you could form a joint venture with them, and they can help promote your products, or even in some homes maybe you can do 50% clay brick, 50% LignoBlock, and slowly as costs come down continue to push more and more LignoBricks.
So Brian says, can you comment on the fire resistance of this product versus clay bricks? And I might add my own, just can you talk about how it compares in terms of how you use it and it's just generally its properties?
Yeah, so I cannot comment on the fire properties. My understanding is there's nothing that makes it more susceptible to fires, but I can't say that it's necessarily more resistant to fires. I think something that's great about it is lignin is hydrophobic. So that means it resists water penetration. So it's really good with resisting rain and breaking down. And wait, remind me your question.
Oh, just general comparing the properties
Yes.
of this to a clay brick.
I had a thought versus clay bricks. What's great about its comparison to clay brick, and one of the reasons why it was chosen, is about 90% of clay bricks right now are used for non-load-bearing purposes, so they're not structurally supporting, it's more kind of design. And right now, in its current state, LignoBlock can't be a load-bearing block. So that's part of why it fits so well as a clay brick replacement.